Okay, everyone. Sorry for the delay. Welcome to October's second Tuesday, which happens to be on the third Tuesday because I'm located in the beautiful Tampa, Florida area, and we've had to deal with a couple hurricanes and mandatory evacuations, but we're here now. And thank you for joining us. Today's session is going to be on named colors or what we call spot colors and special colors, colors that are of great importance in terms of being able to be reproduced correctly across the entire supply chain. We've done little sessions on named colors through the last year, but we've had so many people asking about this. It's more of an advanced topic. And since we've had so many people asking about it, we thought we'd try to do an all-inclusive presentation on name colors. So this presentation's going to cover design, production, post-production, final product. In fact, the agenda is what are name colors, how are they produced, where are they used, how to define, how to select, how to create. Then we're going to go through some designer workflows in terms of how designers can use name colors, because it starts with the designer. The designer has to ideally name these colors to begin with, so as they carry through the workflow, the production workflow, those name colors get utilized through the process so that they render to the correct desired color. We're going to talk about different types of workflows, different levels, and then we're going to talk about how you can incorporate custom lighting. More and more stores these days have LED lighting, which does not illuminate colors the same as what D50 or standard fluorescent illuminates colors. So we're going to talk about that, how to anticipate that. We're going to talk about how a name color can be, let's say Ritz red is 2 delta E with the reference from one sample, but another Ritz red might be 1.5 delta E to the standard, but the two Ritz reds to one another look very different. So we're going to help you understand how even though different samples might have low delta E's to the reference, they might be higher delta E's to one another. A couple things on the G7 forum have come up talking about this very concept. And unfortunately, there's not many programs out there that help you understand these concepts, but luckily, ChromaChecker does help you understand these concepts. Next, we're going to talk about how each print condition, meaning each printer slash paper slash finishing combination, requires a separate lookup table to accommodate how color renders on that device. And we've got some samples here that I'm going to show. Some are off the same printing device, just different post-printing treatments like lamination and different types of coating, and how if you manage your LUT for that print condition, you can have multiple print conditions on coated, matte, laminated, glossy stock, all visually match one another, and I've got the samples to prove it. Then we'll talk a bit about matching name colors on digital devices, and these digital devices can be CMYK digital devices, CMYK orange, green, violet digital devices, red, green, blue digital devices, really doesn't matter. Then we'll dab a little bit into how you match these colors with conventional printing, whether you're doing flexo or offset, where you're customizing a specific ink for the color. Then we're going to get into spot color tint matching and talking about CXFX4 ramps. We're going to cover different variables that affect your perception of the colors, such as OBAs, how different lighting can affect the visual color that you see, as well as predicting metamerism issues, which we'll get into. And then we'll finish off with defining tolerances. And of course, most people use delta E for tolerancing. Delta E 2000 is kind of the ISO standard. I was involved in the equation for delta E 2000, which we started working on in like 96. And you'll see we haven't come out with another formula since 2000 because it's really hard. And delta E as it is isn't perfect. It's not linear, but there's ways around it, such as our snowflake tolerancing, which eliminates the nonlinearity issue with delta E and gives you the ability to visually see the level of color difference, even though it might not correlate to the delta E, it correlates to your expectations. So it's a full agenda today. Please feel free to ask questions in the chat. Beth is going to be managing the chat for us to be able to answer questions as we go. So when we talk about name colors, I mentioned that we have a lot of different issues related to this, and we're covering a lot of ground, and hopefully we'll touch on what's important to you. What are name colors? When designing or manufacturing a product with important colors, such as a Ritz box or a Colgate toothpaste carton, having the right color is critical. And this Colgate could be printed on a flexo process or a sheet fed process or a digital process. And no matter the process, you want that red to match in all situations. So having the ability to call out the color as Colgate red is really important in terms of managing that color throughout the workflow. In the printing industry, the manufacturing process is printed and then could be finished. Like this has a sort of varnish on top of it, which this with the varnish looks very different than this without the varnish. So if you want that Colgate red to be correct under the varnish, you need to build the lookup table after the varnish is done. And we'll talk about how that can happen. So I'm using the term name colors, but you'll also hear spot color as an alternative name. Obviously, most digital presses can't print spot colors, so some people who aren't familiar with conventional presses might be confused because the spot colors, the definition's been a separate ink that goes into the press and printed separately, whereas when we're working with a digital device with let's say a 4-color or even a 6-color process mode, you can't order Colgate red to go into one of the units of the digital press. So we have to simulate the Colgate red as best as the print condition will allow us for that given print condition. So the key is this color comes from the name and the definition. And ideally, the definition should be in spectral data. Spectral data is the, if you will, the highest amount of data related to a color. And for instance, if you're familiar with LAB defines the color with 3 numbers, L, A, and B. Spectral typically defines the color as 32 different numbers. So there's much more information with spectral data, and it allows us to predict things like how is this light going to be affected? How is this color going to be affected by different lighting? What is the metamerism index of this color going to be compared to the reference? These types of things we can do with spectral. We can't do it with LAB. So ideally, in all cases, you should define your colors in a device-independent spectral definition. And the name color is treated independently from other process colors. So if you have a typical printer, you might have the printer set up to simulate grackle. But if you're simulating a spot color, you don't want that spot color to go into the gamut of grackle. If that spot color is outside the gamut of grackle, ideally you want that spot color to render to the actual Colgate red that it's available, especially if the printer has it available to us. So essentially we have a process workflow that goes through ICC profile conversions, and then we have a name color conversion that goes through a lookup table. So it's a completely separate workflow for the spot color. Hence, you don't want spot colors or name colors to have CMYK or RGB values if you can help it. They should be a device-independent colorimetric or spectral value so that it's device independent and can render appropriately on the process. And of course, we use them for brand colors, corporate colors, packaging, and custom inks for different types of print processes. Now, how do we get name colors? There's a couple ways we can get name colors. One is through existing color libraries. So whether you use ChromaSpot, which is a free spectral-based library, go to chromaspot.org. We've done a couple sessions on ChromaSpot, very exciting color library. Or you can use Pantone. The problem with Pantone is you've got you might have the license for, let's say, M2, but not M1 or M0. And so if your lookup table on your GMG RIP uses M2 Pantone and your EFI uses an M1 lookup table for Pantone, you could have that color named perfectly, but through those two different workflows, even if the RIP does exactly what it's supposed to do, the fact that it's using two different Pantone libraries gives you two different results on the two different printers, which defeats the entire purpose. So that's a reason to use ChromaSpot. There's other libraries out there as well, as long as you have access to them.
Okay.
Yes, question.
Sorry, there was a question that says spectral data includes LAB, LCH, density, etc. Can this be measured and then spectral data be applied to a spot color or named color in Adobe design software?
Okay, great question. So essentially, spectral color can be broken into LAB, delta H, delta C, density. When you have spectral data, it's very easy to convert to any other color space. You can't, for instance, go from density to LAB. You can't go LAB to spectral. It works its way down. So spectral is like the top level, and you can derive anything from the spectral. And yes, you can take spectral data into Adobe products. You're not going to see the spectral data. It'll show you the LAB, but ideally, you'll be working with spectral data. So great question there. I hope that answered it. The other way to get name colors is to create it or import it. So let's talk about some of these ways. Now, if someone's going to be communicating color, especially name colors, ideally it should be using the CXF format, which is the color exchange format, which is an ISO standard, and it allows you to communicate colors between different applications. Now, like some ISO standards, it's not, shall we say, well designed. How do I say this? Different vendors have implemented different levels of CXF implementation. So we've gotten to the point today where sometimes we need different CXF files for different purposes. For instance, if I'm running my exact, I save a certain type of CXF file to go into the exact versus a different type of CXF file to go into, let's say, an Adobe product. But it's all the same color in that CXF format. And as I say here, supported by most print workflows. Now, if you're using Adobe apps, you can use the Adobe Swatch Exchange format or the Adobe Color Book to create colors, export colors, communicate colors. And depending upon where these colors came from, that'll determine whether or not their base is LAB or spectral. And ideally, you want to use spectral if at all possible. You can also use ChromaSpot. ChromaSpot, we call it substrate independent, because unlike Pantone, where you have Pantone 185 for coated stock and Pantone 185 for uncoated stock, with ChromaSpot, you have, we'll call it a certain color. So we'll call it a 8R462. That would be like Pantone 185. But that color is that color no matter the print process. So that the color is the color. And I should say the manufacturing process, because whether you're printing on plastic or your fabric, it's the same color. And you want to know, can you make that color or not? You don't want to know if I can make Pantone 185 coated or 185 uncoated, because they're supposed to be the same color, but they're not. Pantone 185 coated is much more vivid than Pantone 185 uncoated. So with the ChromaSpot library, it's one color for all definitions, and then we tell you if it's in gamut or not in gamut. So it helps the communication. And here's an actual scenario showing this. On the left, you've got a coated and an uncoated on a given red, and on the right, it's the same color. And if the uncoated can't make it, it can't make it. At least you know that. And with ChromaChecker, it'll tell you how far out of gamut in delta E that color is from being made, so you can determine if you need to up your budget to get a higher quality fabric or a higher quality paper that will actually give you the color you're wanting to get. Within the ChromaSpot library, there's now an export. So if you've been up on ChromaSpot looking at it, you'll see there's now a download icon on the upper right-hand corner. You have to kind of know it's there. We're going to be labeling it with download so it becomes more apparent. But this allows you to choose colors that are in the gamut of, let's say, if you have profiles for 5 printers, you could load those 5 printer profiles in ChromaSpot and then download only the colors that are in the same gamut that all 5 printers can render. So you don't have to worry about trying to print colors that your printers can't print. So easy tool. The next way you can make a name color reference is using whichever measurement device you're using, whether it's a NIX or a Color Studio or a Nano or an i1 or an Exact or a Teshcon. You take any of these instruments, and then I had this situation at Best Buy where the customer said, our color is this blue on this poster. And so I measured the blue on the poster and I measured it multiple times. And I was getting 3 delta E variation on a solid blue on this poster. So which blue is right? With ChromaChecker's Quick Checker Start Variation tool, it allows you to measure the sample of what you want your color to be, and you measure it in multiple locations, and ChromaChecker automatically calculates what the variation is of those measurements that you're making. And in this sample, you'll see I took 9 measurements. So there's 36 combinations of color. The peak delta E is 1.03. The average is 0.42. The 95th percentile is 0.7. And it shows you the uniformity of this color on your sample that you're measuring. So, and when you save the color, this data gets saved with the color. So if someone starts questioning the integrity of the color that was measured to make the sample, all that data is stored within ChromaChecker, so there's no questioning that the person who did the creation of the color did it off of a normalized and accurate sample. You don't want to be taking an average of colors that are 2, 3 delta E different from one another to make the sample, because the integrity of that sample, when you go to start comparing prints to that original, depending upon where you look on the original, it's going to look different because the original is different. Even though the eye doesn't really pick up on it very easily, it's there. There's a difference there. So this variation tool is fantastic to make sure you get good color. Designers can also build name colors within the creation application, whether it's InDesign, Photoshop, Illustrator, what have you, where you can go in and actually make a color called, let's say, navy blue, define it as a spot color, which is a name color, so it will not be managed as a process color. It will be a standalone color. It will come in as a separate layer as part of the PDF, and that's critical for RIPs and workflows to isolate that name color and treat it differently for different print conditions. Because even the same printer, you print on multiple paper stocks, you need to have different lookup tables for different paper stocks if you want that navy blue to print the same way on the different paper stocks. So we've got to call it out as a separate color. And this way, you can define spot colors as CMYK or LAB, or RGB for that matter. This can help with rendering on your printer, if you're a designer and you're only printing on your printer and you're not necessarily sending it out, then you could do it this way. But even your printer is going to change how it prints RGB or CMYK over time. So even as a designer printing on a single printer, you don't want a device specific definition for your spot or name color. You want a device independent definition. So let's say I change the toner on my printer, or I change an inkhead, and it changes the way it renders color. All I have to do is iterate my lookup table, and I can get back to the color I was printing all along. Last thing you want to do is try to match a color that you could print 2 weeks ago, but because the printer had maintenance, you can't match that color today. And by having name colors in a device independent definition, it eliminates that problem from ever happening. Now, when you're outputting your Adobe or Creative files as a PDF, there's always the option, if you look at the bottom left-hand corner, all spots to process. Don't click on that. Majority of the time, you do not want to click on that, because the second you do that, all your name colors will get blended with process. And then in the sample where I was saying where you've got your printer simulating Grackle, you might be able to hit a red that's outside the Grackle gamut, which is what's actually going to happen on your Flexo press. But because you dumb that name color down to process, it's now going to only render within the gamut of what the printer is capable of producing. And you won't get that nice, pretty red that was out there before. So avoid the convert to process if you're working with a name color workflow. Now, here's a basic workflow for a designer where we're working with this navy blue. You define this navy blue in your Illustrator. You render it on the screen. The profiled monitor will actually render that blue as best as the monitor is capable of rendering accurately, as long as you've profiled the monitor. And then when you go to print or export, you'll see that when you print the PDF, it actually has 4 channels for your process, and then in this case, 2 channels for the spot. And even if this is going to a digital press, it's okay, because the digital press is going to use these 2 channels and look at a lookup table to say, oh, on this digital press, the navy blue is 80 cyan, 40 magenta, 0 yellow, 0 black. Where on this digital press, it's 92 cyan, 20 magenta, 0 yellow, 0 black. So by designating these colors as name colors, you get to have them apply to lookup tables on down the road. As you see here, you've got your production, color defined by name, and then the designer's drafts, if you're wanting to print to a calibrated profile printer, the CMYK data, the process data will render per your profile conversion configurations, whereas the name color through a custom lookup table will render to the RGB value that's necessary to get that lookup table on that printer. Now, a more advanced workflow is where we're dealing with custom lighting. There's been some vendors out there saying, oh, we're the only ones that work with custom lighting. Well, there's at least 4 vendors that I know of now that support custom lighting conditions as part of the spot color definition, and we're one of them. So in this way, if you're trying to match a color to go into, let's say, Home Depot has some pretty funky LED lights. And let's say the manufacturer you're working with has a gray color. That gray color can match all day long under D50, but you put it into Home Depot's lighting, and that color is going to go really reddish. So in this way, you can use a device like an i1 with ChromaChecker, measure the actual lighting from your Home Depot store, and then use that in your design to know that the color that you're creating is going to render correctly under Office Depot lighting, not necessarily your D50 booth. So this is useful. Yes, question.
Yeah, just to back up just a little bit, how would one iterate the LUT, generate a new ICC?
Okay, great question. So the LUT is independent of the ICC, although well, it's independent, but it relies on the ICC profile. So when you have an ICC profile for a given printing device, you then uh, um, build a LUT for that output device. And ChromaChecker has this capability to do a color match scan, which allows you to build a lookup table for 1,000 colors at a time. If you have an automated measurement device like a Milo 9 or an I1 or an ISIS. Soon we're going to add that capability to a regular I1. But we've got sessions, just the last couple months, we've done sessions on how to build these lookup tables using ChromaChecker so that you can have a different lookup table for each print condition that you're going with. And it starts with using an ICC profile, outputting to your print. We did this live, maybe 4 months ago, where I literally measured a color, printed it, measured it again. It was like, it predicted it could be within 0.5 delta E. The first time it was like a 3. ChromaChecker then printed it again. I measured it. It was like a 1.5. I printed it again, measured it the third time, and it was like a 0.5. And then from that point, we're going, okay, 0.5 is really good. I saved that as a LUT. And then that goes into either your workflow, your color workflow, or into your RIP, so that when it sees this navy blue name, it looks at the lookup table and says, oh, navy blue on this printer on this substrate is this combination of RGB or CMYK, and it applies the LUT. So I would have them go back to previous sessions on how to actually build these LUTs. Here's the whole concept is that we ideally could be printing on multiple printing processes, and we have different ICC profile conversions for process color, but then we have a custom spot color lookup table so that when this navy blue prints on the Epson, it's a 87, 46, 12, and 17, but when it prints on the KM1, it's a 73, 45, 6, and 22. The end result is within approximately a delta E of the original, but it used totally different formulas to get you there. And if we were actually deriving a spot color on the KBA press, then we would have a custom ink on press where we'd use ink formulation software to actually build the build of this spot color that we would then do a drawdown or a digital drawdown on and measure what the accuracy of this spot is against the original. And in this way, use ChromaChecker to tell you whether or not the color is right or wrong. So depending upon how the color is being used, digital or conventional, you have different processes to make that happen. And here we're pointing out the different formulas, if you will, to make these colors right. And now this gets to one of the latest G7 forum questions. Person was saying, hey, I've got a 1.3 delta E on my KM1, a 0.7 on my Epson, 2.3 to my KBA, but visually they look very different from one another. Yeah, because theoretically, if we look at this, the KM1 and the Epson could be 2 delta E to one another because they're on opposite sides of the bullseye. In this case, we're showing it as a 1.7, but theoretically, it could easily be a 2. And 2 might be outside the customer's expectations. But you were within a 2 to the reference. They're just not within a 2 to one another. So you have this, think of a clock. You have one color in the 9 o'clock position, one color in the 3 o'clock position, and it can accentuate and even double the amount of a delta difference between these values. So this is very important to understand is that we have these color differences. And if you guys visited us at the Printing United show, you saw these swatch books, and I'm going to talk more about these later. But ChromaChecker now has the ability to build swatch books. And in these swatch books, we document what the delta E is of the color to the reference. So people were sometimes taking a look at these and saying, hey, this one says 0.4 to the reference. This one says 0.3 to the reference. And yeah, they look really close, but they're not perfect. And it's like, yeah, because they could be 0.7 to one another because the reference is in between. It's always to the reference. So people forget that this is, if you will, kind of a three-dimensional equation going on here. And we need to keep this into consideration. Now, when we're building, let's say, a custom swatch book like this for each print condition, you'll see I've got this swatch book for matte stock, for laminated stock, for coated stock, for glossy stock. And each of these required a separate lookup table. So essentially, ChromaChecker builds a target automatically of all the colors you care about. It builds it's not a profile target, but just think of it like a profile target, but with all the colors you care about. So you can do this with ChromaSpot. You can take the 400 color library or the 3000 color library and save it as 300 patches and then print it on your printer. And ChromaChecker knows what the original is for each of these 3000 colors. Then you measure it in with an automated measurement device. And ChromaChecker automatically iterates all 3000 combinations of these colors based on your print condition. And oh, by the way, it'll tell you before you even do the first print, it'll tell you what percentage of the colors are in the gamut of the printer or are out of the gamut of the printer. So you can see and have your expectations set right away that if you've got, let's say, a super vibrant color palette, maybe 10 colors, all 10 colors could be theoretically outside the gamut of that printer. Now, ChromaChecker will iterate to the closest delta E possible, but that closest delta E might be a 5 or an 8 or something like that, which, what is a 5 or an 8? I'll get into this too, but ChromaChecker has a tool that shows you what, for that given color, what is an 8 or what is a 5, so that you can actually get a visual on the screen as well as an accurate printout of what a 5 delta E looks like for your specific colors. This hasn't been done before in the industry, so it really helps you set the expectations of what you're going to get and what it's going to look like. Now, as I mentioned, these iteration steps are necessary for each print condition. So if you varnish, what you do is you print out the 3000 patch target on your printer, then you varnish it, then you measure it, and then ChromaChecker iterates it. Then you print it, then you varnish it again, then you measure it, and ChromaChecker iterates. And yeah, does varnishing it every time take extra time? Yeah, but it gives you an accurate rendition of that varnish as the end result. I've got a sample up here I've shown before where the print is laminated, and we've got processes to make sure the spot color is right after the lamination, because before the lamination, it's 4 or 5 delta E different. It's the same with G7. Before lamination, this print is not G7, but we have a procedure that you can apply to the file so that when it prints, it's not G7, but after the varnish or the lamination is applied, it then becomes G7 compliant. So we really need to take into consideration these post-finishing coating, which greatly affect the color. So here's talking about the CC color match scan, which typically 2 to 5 iterations are required depending upon how good your profile is. If your profile is really good, meaning you used a lot of patches, a real high quality profiling program, you might be 2 to 3. But if your profiling software isn't so good, or you're using a generic profile for the output device, you might have to go 5 iterations. Not a big deal.
Dave,
Yeah, question.
I'm not sure if what you said kind of answered this, but Jeff asks, is there any way to predict how lamination can affect the color if you have spectral data of the lamination? Is that kind of what you know?
So if you have a profile of the lamination, ChromaChecker can absolutely predict whether or not that color is in gamut or out of gamut. Yes. Good question. Okay. So here's an actual screenshot of some of these chipbooks that I'm showing in my hand right now. And you'll see over on the right, you see where it says 0.1, 0.2, 0.3, 0.3. So these chipbooks were built in a very automatic way using ChromaChecker and the color match scan. And 3 different LUTs were created. We covered this in the July 2nd Tuesday event. And you can see on the screen here, they're a really good match. Now, here are the lookup tables. So you see sample 1, N90, that's the CMYK build for it. Here's the CMYK build for the same color with no finishing. Here's the same build for a matte finish. So different print conditions, different results, or different print conditions, different lookup tables, but the same result. So you can see the delta E's are extremely small. These are the 6 samples on this first page of the chipbook that I'm showing. And of course, I'm showing gray because it's the easiest to see color differences in gray. Okay, and look at those delta E's. Obviously, the more iterations you do, the lower delta E's you get. And you can see, again, the chipbooks are labeled automatically. You don't have to do this. Now, it's important to understand that when we're dealing with darker colors, like signal black, which is a real dark black, I have to go to my chipbook to show this color, but the matte, because of the matte lamination, it lightens up the black color. So using the matte lookup table, ChromaChecker predicts the delta is going to be 5.66. And you can see it's using the maximum amount of ink, almost 400% ink, not that you ever want to do that, but it's just telling you, hey, if I max out all my inks, I'm still almost 6 delta E different from the color, and it's because of the coating. Hence, why you need different lookup tables for different coatings. And it can go either way. Coating can enhance the color, so it can actually increase the chroma or the vividness of the color, or it can decrease. So here's a scenario where we've got the same color on 3 different chipbooks with 3 different coatings, and you can see the gloss reduced. The middle is the unfinished. The one on the left is the gloss. So by putting a gloss finish on it, we got closer to the original, to a 3.3 instead of a 4.1. This is the unfinished. And then if we apply a matte finish to it, it goes from a 4.1 to a 6.6. So again, the communication that ChromaChecker gives you in terms of what's going to happen with this color based on the post-finishing effect is really useful. Now, to get into conventional workflow where you're actually doing ink formulation, this is for flexo, gravure, sometimes sheet fed offset, things like that. Well, this is where you use CXF and ink formulation software to essentially build a drawdown. You apply the finish to the drawdown, you measure it, and then we tell you how close it is to the original. And ideally, the ink recipe will fix the ink through the addition of other inks or the reduction of other inks in the initial ink formulation to get you to the color that you need to be at. And CXFX4 gives you the ability to characterize this data. It's essentially 10% ramps over white and with a black print over top of it, which helps us understand the opacity of the ink. And in this way, we can use it as process control. And soon, ChromaChecker will have the ability to calibrate using SCTV these spot tints to be the right color. Because in SCTV, in this, let's say your spot tint's a purple. You want the 50% purple to be half the delta E between solid and paper white. And SCTV calibration helps create this spot color lookup table so that when you're dealing with tints, you can get accurate tints throughout your workflow and throughout your supply chain. So again, some more information on CXFX4 for the sample. So CXFX4 can be used for quality control to know that you're printing the way you're supposed to be printing. You can use it for spot tint dot gain curve, and you can use it to iterate a dot gain calibration curve to help your spot color fall in line with SCTV. And by the way, SCTV is spot color tone value. And this is what you see in Illustrator. When you look at a spot color in Illustrator, it renders it. If you do a ramp of solid to paper white, the 50% is half the delta E between the solid and the paper white. But if you try to print that without SCTV, chances are the 50% visual delta will be in anywhere from the 70 range to the 30 range, because spot colors can be very unpredictable in terms of how they lay down in tints. So that's why SCTV is so important, so we can actually get control of our tints for our spot colors. And of course, you can't even do this unless you have spectral data. So going back to that second slide, try to do all your spot definitions in spectral so you have the ability to do this type of thing. Other capabilities that name colors give you the ability to see and do have to do with lighting conditions, fluorescence, and metamerism. So I'm going to talk in a little more detail about all these. So this is a concept called color inconstancy. And what it means is how volatile is this color under different illuminance or different lighting conditions. So here I've got a red, and you'll see under D50, the color's the right color. It's because it was defined under D50. But if I go all the way down to the right here, these last two columns are allowed for custom illuminance, like an Home Depot orange LED light. Well, this red under Home Depot LED light's going to change by 18 delta E. Are you kidding me? In fact, we give you a simulation of what that difference is going to be. So in this way, you could design something all day long under your D50 light booth. You bring it in Office Depot or Home Depot and it's 18 delta E off, and everyone's going to be looking at you going, do you not know what you're doing? And it's all due to the lighting that's being used. So being able to predict the volatility of the spot colors, this gets back to when you're creating the colors, you should check the volatility of these colors. And ChromaChecker gives you the ability to do that. When you measure a color, let's say you're creating a new spot color for some brand that's their product's going to go into Home Depot. When you measure the color, ChromaChecker has a tab here called CII, Color Inconstancy Index, and you can load it with standard illuminance as well as custom illuminance to see how volatile that color will be under the different lighting. So you can know whether or not we should use that color or not. Maybe we need to redefine it so it's not as volatile. Fluorescence index, or the FI index, and OBA index, tells you how the light is, how the color is going to be affected by UV light, ultraviolet light. And so down here, the higher the OBA index, the more volatility that color is going to have under UV light versus non-UV light. So most LEDs that you find in stores don't have UV in them, but sunlight has UV in them. So this is where, again, you can have a lot of volatility between how this color looks under sunlight versus a store lighting condition with LED lighting. And then metamerism index, this is another tab underneath ChromaChecker Quick Checker. This tells you how different the color is going to be to your reference color under the given lighting condition. So this says, okay, we've got a color that we need to match for this manufacturer. This manufacturer is building, we'll say, carpet. And we're using our CC spherical instrument to measure the carpet. And we want to know that the label of the carpet matches the carpet when it's under Office Depot orange LED lights. This tool will help you predict the match of your new sample versus the reference under Home Depot orange LED lighting. So you can know whether or not you've got a problem or if everything's going to be okay. And if you've got a problem, you can then fix the definition of the color. So change the definition of the color so that it matches the original underneath the Office Depot lighting without, Home Depot lighting, without ever going into Home Depot. So this is the power of predictability, the power of spectral data, and the power of knowing how to use it. Now, we're getting into a pretty advanced topic here, but we've got users that operate at this level. And you might not be at this level now, but you'll get there. You'll work your way into it. And let me just plug, we're going to be talking a lot about this type of functionality at the Color Conference, which is coming up at the end of January in Newport Richey. Newport Richey was spared for the most part, the majority of the damage from the hurricane. So I've already checked in with the 3 hotels that are hosting the conference. One is where the conference is at, that's the Quality Inn, but people were not super happy with the Quality Inn rooms. So we have rooms blocked out at the Comfort Inn and Suites, which is brand new this year. It wasn't even open for last year's conference, as well as the Hacienda, which is my favorite. It's on the river right downtown. And we have shuttle service this year, both morning and night, to get people to and from the conference. So even if you're not staying at the Quality Inn, you'll have a shuttle service to get you back and forth from your hotel. And we are having a boat trip again this year, and the shuttle service will bring us to the boat trip as well. So I hope you guys join us on that and learn more about color. Now, we're not done with this one yet. We've got a couple slides left. We've got a couple minutes left. So when we're talking about tolerances, I kind of alluded to this earlier, is that delta E is not linear, especially with certain colors. And so people will often say, oh, I want a 2 delta E. Well, 2 delta E can be really hard for the manufacturer to make, you, the printer, to make. And so it's in your best interests to get them to back off a 2 delta E, maybe go to a 3 or 4. And here's a great example of what a 3 delta E looks like for kind of a light color. And I hope this is showing up pretty well, but Beth, you can chime in. Are these circles at the top and bottom the biggest differences that you see between all of these side patches?
Yes.
All right. So every combination of a 3 delta E is being shown on this graph. There's like 22, 24 different 3 delta E combinations, and only 2 of them are, if you will, obnoxious, meaning I can live with pretty much all of these color differences. I can't live with that color difference and that color difference. So this tool from ChromaChecker called Variator helps you communicate to customers on what delta E is for any color. Because what looks like a 3 delta E in this color is different for a green color, which is different for a red color. So when people just spout out 2 delta E, it's like, okay, you could be making things unnecessarily expensive for you, the client, and unnecessarily expensive for the printer. So now that we see 3 is acceptable, except these 2 cases, then we can go to the snowflake tolerance. And what the snowflake tolerance does, I don't have snowflake for this exact color, but the concept is you can keep the delta E for the A and B axes, which is your green, red, and yellow, blue axis, and just cut it short for the light, dark axis, which is where these 2, that's the light 3 delta E, that's the dark 3 delta E. There's still 3 delta E, but it looks like 4. But when I cut this down using snowflake, now visually, what's acceptable will actually be less than 3, but only for the light and dark. For everything else, it'll still be a 3. So you as a printer have a lot more latitude to reproduce that named color in your manufacturing process. And you as a designer, you don't get hit with false fails where something looks like it's okay and it's not, or false passes where something says it's okay, but visually it looks bad. So this is where the snowflake tolerancing comes in. And in this way, it's 6 times more accurate than delta E. It allows you to set up your delta plus A, plus B, minus A, minus B, plus L, minus L, to set your tolerance. So it's a visual tolerance to the color, not some arbitrary delta E number that doesn't stay visual to the eye. And like I said, I was on the committee that helped test the delta E 2000 formula. We haven't come out with another delta E formula because no one knows how to do it. There's not the math, it's not possible. The way to fix it is with the snowflake tolerancing. So it still uses delta E. It tells you what the delta E's are. This doesn't obsolete delta E. It just refines delta E and refines the fact that delta E is not linear. And what customers want is a visual representation of the print that matches their expectations. And that's what this does. So, like I warned you, we're covering a lot in this session, but hopefully you've got a better understanding of what named colors are. You know how to create and apply in the workflow. You have a sense of how you can accommodate different lighting, as long as you have a measurement device that can capture the lighting and store it. You can understand the difference between the standard and between samples. So if I'm looking at these chipbooks here, this one's 0.3, this one's 0.2. Well, theoretically, they could be 0.5 to one another, okay? Because the standard's right in between them, and one's at the 3 o'clock and one's at the 9 o'clock position. We talked about how to iterate for each print condition. That makes a lookup table using our color match scan and our color match spot. And sometimes you don't need to iterate the CMYK or the ECG data. You need to actually build a formula for the ink in conventional, especially with gravure. So, and in Flexo, where you're not doing a process simulation, you're actually building the custom ink, which ChromaChecker workflow supports completely. And then we talked a bit about how you can use ChromaChecker to do metamerism prediction and custom lighting to your advantage, so that you know how volatile the light that you're using your named color in, how volatile that color will be under the different lighting that sample could be looked at under. Because ideally, you don't want the color shifting if you can help it. And then the ability to migrate from using delta E tolerancing for your spot colors to snowflake tolerancing. And I can't tell you how many people at the Printing United show, when they heard about snowflake tolerancing, said, you will make my life 1,000 times better if you eliminate the false fails and false passes that I experience every day working with Delta E. And I said, that's exactly what this does. It eliminates all those false fails and false passes. And it's so easy. It's a tool. You look at it. Last year at the Color Conference, we had a workshop on it. We'll probably have another hands-on workshop on it this year because it is so new. People are really interested in it and they want to get to know it better. So we'll be doing a workshop on that session at the conference. And bring your computers because we will definitely have hands-on again so that you can not only hear the theory like you did in this session, and I apologize I didn't do more hands-on of actually measuring, but I'm still kind of getting my office together. If you see my wall here, I had to take out the bottom 3 feet of my wall because I had 2 feet of water in this room a couple weeks ago. So I'm still getting myself up. But using these tools, you can really improve your process and deliver higher quality results to your customers. Are there other questions that anyone has for this seminar?
I don't see any more questions in the chat.
All right, well then I'll stop recording and this should be available next week, or actually in a couple days. But I want to thank everyone for coming.